Introduce Ken. So Ken Fleischmann, he's a professor of School of Information here at UT Austin, and he's a founding chair of the executive team of the Good Systems. And so it's a big effort here at UT, and that's what he's going to talk about today. He's also a founding director of the undergraduate studies for the iSchool's bachelor degree for informatics. His research and teaching focus on the ethics of AI and more broadly, the human value, the roles of human values in the designs of the information technology. So Ken has won many Best Paper awards, probably too many for me to cover. And one fun fact I'm just going to say is that Ken actually did his undergrad in double major in computer science and anthropology, and then he went to do a master and PhD study in science and technology studies. Why that caught my attention is because my wife is an anthropologist, so I know what kind of interesting conversation can happen between robotics research and anthropologists. And Ken is the one who speaks both languages, right? So I think his talk is guaranteed to be interesting. And so without further ado, Ken, the floor is yours.
Thank you so much, Yuki. Really appreciate it. Thanks, everybody. Okay, so today I'm going to talk about Good Systems UT Grand Challenge. This is one of 3 campus-wide research grand challenges that we have here at the University of Texas at Austin. These are 8-year moonshot initiatives to explore new areas in ways that are societally relevant. And that's where the computer science anthropology combination comes in, understanding both the human and the technology and trying to put them together. We have an incredibly diverse team. Actually, one thing that's really different about Good Systems relative to many other grand challenge initiatives at other universities is our initiative was really done, the Bridging Barriers Research Grand Challenges were done from the bottom up. So it's usually at most universities, the president, the provost, the VPR sit in a smoke-filled room and decide sustainability and cancer, that's what we're going to focus on, whatever they think the hot topics are. Here, the administration actually trusted the faculty and enlisted the faculty's assistance in coming up with white papers that would propose grand challenges for the campus and then connected us. So it's actually Peter's white paper on, there were many white papers that went into Good Systems, but I would say that Peter's white paper on ethics of AI was the one that's at the heart of Good Systems that led to bringing together people who wouldn't otherwise have met each other. That was how Peter and I met. It was how many of us on the executive team met. And it was really an honor to get to be the founding chair of Good Systems and lead us through that process of getting approved and launching. So we launched on the fall of 2019, so we're in our 3rd year right now. As the president described, we are working to ensure that the needs and values of society drive the design of AI technology. So we focus on ethics of AI and ethics of robotics. So that's the focus of Good Systems UT Grand Challenge. And so this slide describes we're bridging barriers between disciplines. Of course, at many universities, including at your universities, it can be challenging to interact just between electrical and computer engineering and computer science, let alone anthropology and computer science, or the School of Information, where I'm a faculty member, and computer science or other units across campus. So here we have, I'll have a slide later about the range of different units that are participating, but it's over 35 different units across campus participating actively in Good Systems. And these are, again, moonshot initiatives with big goals. And of course, AI and robotics are touching just about every part of our lives and are poised to do only more in that regard. And it's really important that we're using them as a force for good in society. We're using them as a force for equity, a force for justice, to make the world a better place. So again, AI is in all of our lives. There are all these unintended consequences. So this is part of the challenge. Of course, we like to work fast, break things, see what happens. So actually the quote from Ian Malcolm in Crichton's Jurassic Park I find inspirational. Your scientists were so preoccupied with what they could do, they didn't stop to think what they should do. So this thought process, this decision of like, what might happen, how might it occur? It's hard to predict in all cases what are the possible consequences of technology, but it's important to be thoughtful about that and not just, that's someone else's problem. We really can't afford that. Of course, in medicine and in law, we have licensing that can be revoked. So you can lose your license to practice law or medicine because those are life or death professions. Because you might be on either side of a capital murder case, You might be saving a patient in an emergency heart surgery. Technologists are increasingly also doing things that are life and death situations. If you're designing a Boeing 737 MAX 8, that's a life or death situation. If you're managing a robot that, one wrong move might kill 8 assembly line workers, that's a life and death situation. We don't have that same recognition and that same licensing for roboticists and other technologists, but we have that same responsibility. It's really important that we're considering that seriously. At the same time, the lawyers and policymakers, if you've seen some of the hearings on Capitol Hill, still talking about vacuum tubes and having no understanding of the business model of the social networking companies, you can really see that we have a big gap between technologists need to think more about the societal implications, and the lawyers, policymakers, other folks on the societal side need to better understand the technology and what might happen. We need to bring those expertise together. That's what Good Systems does. So the Good Systems framework is about defining, evaluating, and building. So we define what it means to have a good human-AI partnership. And so part of that is defining good, but also part of that is defining the system. And the system is not just the technology. The system is a socio-technical system. So it includes the humans and the technology working together in a partnership. We want to evaluate the goodness of systems, existing systems, that we can improve upon them, as well as once we built our systems, evaluate their goodness so that we can assess the degree to which they're really meeting our goals and criteria. And finally, how we can build human AI partnerships that benefit society. So at the end of the day, we want to build something, we want to put it out there, but with an understanding of what's going to happen and with careful evaluation of making sure it's achieving what we want it to achieve. So again, AI technologies are helping us solve complex problems in nearly every discipline and industry. So our grand challenge is to design AI technologies that benefit society. So these are the collaborating units. Again, over 35 different departments. Actually, that was an old count from before. We have just announced our summer faculty fellows, summer graduate fellows, and we're hiring some undergraduate research assistants for each of our 6 core research projects as well. So we're significantly expanding the scope of Good Systems, which is already pretty broadly across the campus, you can see. So you can see, again, I'm a professor in the School of Information, so you can see the iSchool. You can see computer science, of course. You can see many different departments in the Cockrell School of Engineering. You can see the LBJ School of Public Affairs. You can see TAC. You can see the UT Libraries. Pretty much spans the spectrum of the campus. You can see College of Liberal Arts, English, for example, there. So these are some of the units, architecture, some of the units that our executive team are from, also the Moody College of Communication. So really, again, spanning the spectrum of the campus. So we launched in the fall of 2019. We started out with 10 one-year projects. We organized a conference on informatics education in March 2020 with funding from the Public Interest Technology University Network, which focuses on making sure that technologists not only go into jobs in industry, but also that we have good technologists in government and nonprofits, so we don't have situations like healthcare.gov that crashes, and for the first several years, everyone hates a new law simply because they couldn't build a good website. So then we have actually, in our second year, we focused on collaborations with the city of Austin. So we played a role in the contributing to the development of a master interlocal agreement between UT Austin, the city of Austin, which is a 5-year partnership between UT and the city. And in our second year of the 11 projects that we launched, 7 of them were direct collaborations with the city of Austin. And several of our core projects that I'll talk about in a moment are also in collaboration with the city of Austin. And we partnered with World Economic Forum last spring, and then we launched our 6 core projects. So I'll talk about those 6 core projects a bit. I just wanted to give an overview. There's a lot of work going on, a lot of brilliant people involved in Good Systems, but I wanted to give you a taste of some of the work that's going on across all 6 of the core research projects. So before I get to that, though, these are some of the first-year projects that we've done. So the AI Austin housing analysis, looking at housing affordability. Urban health risk mapping, another important issue, is seeing where, of course, there are huge disparities in terms of the health impacts of pollution, for example, environmental justice issues. Optimizing EMS response, so actually improving the time for EMS response. Again, life and death, that 88 seconds could be someone's life that you've just saved potentially. And then another project, AI equity and homelessness. This project was really funded by Good Systems. It's now funded by the City of Austin in partnership with the Downtown Austin Community Court, and was recognized as the Metro Lab Innovation of the Month for July 2020. So a lot of exciting projects, but we did 2 years of one-year projects, and that gave us a taste of kind of what are the important areas in ethical AI and ethical robotics. But we wanted to do deeper investments. We didn't want to spend 8 years just doing one-year projects. So after 2 years, we formed 6 core research projects that form the remaining 6 years of our 8-year mission. So those 6 core research projects are AI and racial justice, being watched, curbing disinformation, smart cities, living and working with robots, and smart hand tools. So I'll talk about each of those projects in turn. So AI in the future of racial justice focuses on achieving racially equitable AI, focusing on important applications such as public safety, transportation, and health. And in partnership with the City of Austin, for example, with health-based organizations and community stakeholders, again, defining, evaluating, and building what it means to build racially just AI technologies. And so the leads for this project are Craig Watkins from the School of Journalism and Media here at UT, Chandra Bhatt from Civil Architectural and Environmental Engineering, and Min Kyung Lee from the School of Information. Another project, Being Watched, Embedding Ethics in Public Cameras. So here the focus, of course, we have cameras everywhere. They can be very useful, but they're also, can raise some interesting privacy issues and concerns. So how can we enhance access and usability and improve social acceptance of these cameras and video data while handling issues like privacy? So how do we mitigate privacy risks and manage those risks? Actually, we had a great talk by Ed Cottrell from Microsoft Research a few weeks back in our Good Systems Symposium. One of the points that Ed Cottrell made in his talk was, we often think of these as trade-offs. So on the one hand, there's like so much information we can get, and in terms of safety, for example, that we get out of having a camera, but we also have this risk in terms of privacy. We often think of how do you balance that trade-off between safety and privacy? But in some cases, let's think about, are there ways that we can optimize and design for both? So can we design technologies, design systems that both safeguard privacy and promote safety, and do those together and try to advance both? So in many cases, we're trying to take these values and not just thinking of them as pure trade-offs, but how can we optimize for both? And so the leads on that are Sharon Strover from the Moody College of Communication, Maria Esteva from TAC, and Atlas Wang from Electrical and Computer Engineering. Another project is on the important issue of disinformation. So of course, disinformation is part of our everyday lives. It's been a huge issue in terms of how it's so easily spread via social media. And so here, the researchers are applying explainable AI to study disinformation, because one of the challenges with disinformation is getting people to trust any kind of labels, whether they're human or machine generated. Who is generating that? What's it based on? Why should I trust it? Why should I believe it? So if you use explainable AI, at least you can show some of the underlying data. At least you can try to provide a basis for that, and not just trust me, I know better than you. So that doesn't work very well for most people. And also working to ensure fairness and bias mitigation in the NLP work that they're doing. So that's co-led by Matt Lee from the School of Information and Diraj Murthy from School of Journalism and Media. Good system for smart cities. So in this project, their goal is, as it says, build a digital twin of the city of Austin, and to basically take all the data that's out there. And Austin does have an open data portal. It's got a whole bunch of data there. but it can be challenging to actually navigate that data and make good use of that data. Other organizations, entities, agencies have data as well. That data isn't necessarily interoperable. So trying to make that data interoperable, trying to identify data bias, there are a lot of limitations with data. Actually, Meg Maratha has done some really important work. A student at University of Michigan School of Information has done some really important work on how data for epilepsy and how physicians diagnose epilepsy and how they're defining a seizure. And if I understand Meg's work correctly, basically you would think of that as being an objective measure that would be based on, you know, how many of seizures per period of time. But in fact, Meg was able to identify cases where physicians were, you know, interpreting what did and didn't count as that episode based on what diagnosis it might lead to, which aligned with what they thought was best for the patient. So another case actually from our own work on the AI equity and homelessness study was one of the questions. There's this instrument called the VI SPDAT. The VI stands for Vulnerability Index. Basically, it's used as an assessment tool to figure out how, you know, for triage, how much need someone has for care. Basically, how likely is someone to die if they're in their current situation without any kind of services provided, to prioritize services. And so one of the questions on the instrument is, do you have access to food? And one of the participants said, yes, I do. And the caseworker who was administering this actually knew this person and understood their life and had seen them getting access to food. And they said, oh, do you mean when you get food from the dumpster? And they said, yes, that's what I mean. And then the answer is no, they don't have a, you know, steady, secure access to food. But, you know, based on the instrument, based on how the participant understandably interpreted the question, they were going to answer in a way that would get them less care while they needed care. So the data that we have is often very unreliable and very problematic, even unintentionally. That's an unintentional case where someone is accidentally disadvantaging themselves just based on how, you know, maybe the question could have been written more clearly based on their interpretation. So the co-leads for that are Zhenfeng Zhao in the School of Architecture, Nok Tran in math, and Wei Jiaxu in tech. Okay, big one here, living and working with robots. And actually, we've got many of the co-leads of this project here in the room. So, sorry I hope I don't butcher this too much. Apologies if I do. But as I understand what Peter and Joydeep and Luis and others are doing is designing autonomous service robots to interact with people on UT Austin campus. So they're designing robots to uphold human values, not cause unintentional harm, improve campus quality of life. And so to see robots as a good addition to the campus, actually working and interacting in real environments. So I know one of the partnerships you have is with UT Libraries to deploy them at the UT Libraries in a meaningful case. And another is actually with Houston-Tillotson University, because once you've tried UT Austin, it's important to try in other settings. And Houston-Tillotson is the oldest university here in the city of Austin, also HBCU, and is a partner on that project as well. So it's really exciting to see sort of citywide deployment, starting here at UT, then to HT, and then, you know, across the entire city. So it's a very ambitious, very exciting project. And too many co-leads to list, I guess. Okay, Sam Baker, English, Joydeep Biswas, Computer Science, Aaron Choate, UT Libraries, Justin Hart, Computer Science, Elliot Hauser, School of Information, Katie Pierce-Meyer, UT Libraries, Louis Sentis, Aerospace Engineering, Samantha Shorey, Communication Studies, Carrie Stevens, Communication Studies, Peter Stone, CS. Okay, and then the last of these, sorry, I know this is quite a whirlwind tour, but the last of these is making smart tools work for everyone. This is a core research project that I'm co-leading with Raul Longoria in the Walker Department of Mechanical Engineering and Sherry Greenberg from the LBJ School of Public Affairs. So we're designing smart hand tool systems that empower workers. So we're looking at applications like manufacturing, construction, maintenance, repair. Of course, there are increasingly robotic solutions being created in those contexts. And increasingly, this is threatening blue-collar jobs in many cases. We're looking at, can you take the tools that workers are using that probably haven't changed much beyond ergonomics for many years, And can we give them some sensing capabilities? Can we leverage IoT and edge intelligence to actually give workers feedback to help them learn faster, learn better, avoid repetitive stress injuries, avoid workplace accidents? Can we broaden the middle school workforce? So there's really a gap. One of the applications, one of the occupations we're looking at is welding. There's a huge gap in welding in terms of the many jobs that are available and the relatively lower number of skilled welders that are here in the workforce here in Austin, Texas, and also nationwide. So a lot of middle school jobs, there is a gap, there's a need for more skilled workers. So being able to expand and broaden the workforce in terms of education, in terms of ability, would be a way to address this middle skill gap and to keep some blue collar jobs. So that's the purpose of the Smart Hand Tools project. So these would of course be networked together, and there would also be a digital twin. And this way we're going to be modeling the use of the tool and observing how the worker is using the tool and optimizing for the worker's use of the tool. And so we're starting, this was our sort of toy project. Again, we're using welding as our main application now, but we're using a small rotary power tool. As you'll see in one of the next slides, we have quite a team of people with very different backgrounds, so we wanted to make it pretty safe. But also it has, we use 4 different bits. So you can then have 4 different activities and you can try to sense the activity. So eventually what we're trying to do is to be able to, help novices learn from experts. So to be able to detect the skills that experts have and help novices to acquire those skills. But the most fundamental thing, before you can run, you have to walk. The most fundamental thing is to figure out what activity people are performing with the Smart Hand tool. So we did testing with these 4 different bits in order to figure out. And so we had a lot of engineers, but also we have a sociologist and a lawyer on our team. So we had actually one person not pictured here. So 7 different testers of the technology that we were assessing this with. And for the sensor data, we had all these sensors. So acceleration, body rotational velocity, magnetometer, and also the current and the sound. And so based on this, we were able to model, and so here's the confusion matrix that we got for these 4 different activities. And this was a very early pilot. So in the first year of a 6-year project, and this is work that we did in the fall, but we're able to, very well predict the which activity is being performed. But the next thing is which worker is performing it, then differentiating skill in terms of highly skilled workers versus less skilled workers, and then identifying gaps, identifying lacks of skill in the less skilled workers that you can give feedback in order to help them to perform as well as the high skill workers. So that's the trajectory of that project where we're at right now. Again, Sherry Greenberg from LBJ School of Public Affairs and Raul Longoria from the Walker Department of Mechanical Engineering are our main collaborators in this project, but it's also a broad team across many different units on the campus, as is the case for all of Good Systems. So just really fabulous folks to get to work with. Coming soon, we do have some things going on here on this campus. One is we have a portfolio program in ethical AI that actually Luis and Peter and a bunch of us are working on. And so I guess Joydeep will have this pretty soon. I think, so Zhenfeng Zhao, who's the lead, just submitted the paperwork earlier this week. So we're waiting to hear how this is going to turn out. But a portfolio program here at UT Austin, it's sort of like an interdisciplinary minor for graduate students, either master's or PhD students. So it's a collaboration between the Department of Computer Science, the Department of Aerospace Engineering and Engineering Mechanics, the School of Architecture, and the School of Information. So that'll be a great opportunity for our students and a great chance for that kind of interdisciplinary interaction. Students take classes from 3 different departments in that portfolio program. And Luis has a really awesome robotics course. Joydeep does as well. Peter's going to be teaching a really awesome course as well, along with Tina Peterson. So that's going to be really really exciting course in Introduction to Ethics for AI and Robotics. And then last thing is that there's a new journal that's going to be launching, the ACM Journal on Responsible Computing, which is going to be carrying forward the focus on ethical AI and basically good systems approach to focusing on what is it that technologists should be thinking about as we design and deploy new technologies. I'll be the editor-in-chief of this new journal, and we're going to have the website launched this summer. We're planning to publish our first issue next year, our first volume. So please stay tuned and definitely keep us in mind as a potential venue for your research down the road. And Peter is serving on the advisory board for the journal. Awesome. So thank you all very much. Any questions?
Thank you, Ken, for this overview. I think this good systems work is fantastic. I'm really happy to see the support and the enthusiasm from the community around this. In thinking about it, I think it's very important, as you've highlighted, to teach the practitioners to think about these things and put them at the forefront of their mind when planning experiments, when planning ML systems, deployment, operations, et cetera. The other side of it is, as you highlighted, the lag that exists in policy. And I was curious, not so much from your own work, because I know that you're very much a researcher, but is there any sort of tie-in to the LBJ school and essentially lobbying, right? That's how you make policymakers care about the things that you care about, is through lobbying efforts. That's how you educate them. That's how you raise awareness and bring forward the great research that's coming out of good systems. Is there a policy influence side via lobbying that exists via good systems, or is that an entirely separate activity?
It is absolutely part of, that's a great question. Thank you so much for that great question. It's absolutely a key focus for good systems. We were fortunate to add 2 members to our executive team recently. Luis Sentis is one of them. The other is Sherry Greenberg from the LBJ School of Public Affairs. Sherry was in the Texas House for 10 years and also served as a special advisor to Mayor Adler. So she's one of the most connected people in the city and in the state, and also a great scholar in public affairs and public policy. So one of the first projects, actually around the time that Good Systems was being launched, we had funding from Cisco Research to look at that gap that exists. And so we interviewed AI researchers. We also interviewed folks in policy and in law, and identified some of those aspects of the gap. And part of what we're trying to do is to train interdisciplinary folks on both sides. So not just to get the technologists to be aware of the societal implications, but yes, also thinking about in terms of public policy and law, how to get folks more trained and educated and proactive. That is, we in our informatics major that I'm the executive, that I'm the director of, we have a required ethics course as part of that. And we're creating this, group of very socio-technically expert folks going in. One of the outputs of the work that Sherry and I did was to do a white paper for the Day One project, which focuses on they come up with proposals that would be things that a new administration could come in and start to launch. And so we propose to increasingly centralize AI, sort of centralize, but also connect AI research and AI policy to make sure that the research was driving the policy and that the policy was informed by the research. We have seen some progress in that regard in recent years in terms of trying to connect those. So it seems like there's some progress. There's still a lot to do, but yeah, Sherry Greenberg is really our sort of local expert on the team. And since she's co-leading the Smart Hand Tools project with me and Raul, that's been a great opportunity to think not only about the technology, but also the impact it's going to have on society. And of course, jobs and job loss, job creation, and manufacturing in this country right now. We've seen the issues with supply chain during COVID. Of course, some countries are still having lockdowns, and as well as we have, of course, some very unfortunate situations going on in the world right now. So that's all disrupting our supply chain. It's really important that we're thinking about how we can, make sure that we're still manufacturing here in the US, and we think our work would help to achieve that. Great question, thank you.
Anyone else? Over there.
And I'm loud. What a great system. Wonderful. Something we can do. Let me follow up on that. The systems requires understanding the domain in very domain-rich areas. How are you training the students to do the research? Not the ethics and the policy, all very important, but the actual domain analysis and working with it. How are you structuring that?
That's a great question. So, and our this portfolio program in ethical AI is a part of that. So there are domain courses in robotics, for example. I know that like the work that Joydeep, that you do in robotics, and that Luis and Peter do in robotics, that you're actually collaborating with the domain experts. So, I mean, there are 2 members of the UT libraries on the team. So in that sense, when they're actually thinking about deploying in the UT libraries, they have folks with that expertise. And also across that team, we've got aerospace and engineering, CS, lots of different disciplinary expertise. I think what happens in a project like this is the students that we're training are inherently learning interdisciplinarily from the get-go. So any student that Peter has now is not like purely a CS student. They're going to have that hybrid expertise. Peter, go ahead.
Of course, as Ken mentioned, that Peter and I are talking, there are meetings, bigger than ethical AI in robotics, but it's not just robotics, but the domain that they're thinking of focusing on, first time it's been talked with still in development, but is COVID response, pandemic response. We've developed a simulator collaborating with epidemiologists here on building a sort of agent-based model of pandemics that we can then have students come in and think about what kind of interventions could be made from an AI perspective and what will be the ethical implications, societal implications. So very much in the context of a domain that's been built up with these consultations. How are the experts in that?
Yeah, thinking, and that's so interesting. And in this whole idea of the simulation and modeling with the digital twins, thinking about the ones like the smart tools and the EMS. Are you using a Delphi cognitive work analysis? Are you training your students in those formal methods, or is it more we're building the system and then letting everybody explore together?
Yeah, I can speak best to the Smart Hand Tools project since I'm co-leading that initiative. So for that project, we're doing participatory design and value-sensitive design throughout the design process. So we're actually going to be our next 2. Okay, so I should have mentioned that as we were doing the Smart Hand Tool in the lab, the rotary power tool, we were also interviewing students from Longhorn Racing. So Longhorn Racing is a group here on campus that builds combustion, electric, and solar vehicles. And so we're interviewing students about their tool use. They were the ones that highlighted for us how welding was the really challenging application for what they were doing. So we just put in a proposal based on the application of Smart Hand Tools to welding and building smart welding tools that came from interacting with our student participants. Of course, those are UT students, so we really want to go out in the field. So we're now exploring interviewing blue-collar workers, and specifically blue-collar workers who will need accommodations in their work, and trying to understand what accommodations they would need and how Smart Hand Tools could adapt for that, as well as the training process and how folks learn to weld and how we could maybe improve and speed up that training process. So those are some, and we're collaborating with and gathering data from participants using work from more of a qualitative social science perspective primarily. I hope that helps. Thank you.